here we are, DSPy Boston. In case you can't tell, I love DSPy. Got I think the first Celtics DSPy jersey, and I'm just so excited about DSPy Boston. We've got Omar coming to MIT, bringing these incredible PhD students working on DSPy, and it's just an awesome community. Not only is the tech is great, but also it's just a great community, a lot of smart people working on it, and it's just really fun to be a part of. Awesome. So as Erica mentioned, I'm going to kind of contextually tell a little more about our story with Weaviate and kind of how we see our role in the DSPy community and some things that we're building. So this talk is going to be about compound retrieval systems, our journey with Weaviate agents, Weaviate's query agents, search mode, and open sourcing Retrieve DSPy. So as Erica mentioned, we're trying to move up the stack at Weaviate, and we built this great open source vector database that has all these things like vector search with pre-filtering and Acorn for improving that, multi-vector support, Colbert late interaction, rotational quantization, all the things you'd expect from a state-of-the-art vector database. And we're also moving out into becoming an AI native database with these database agents. So in March 2025, we released 3 of these agents: the query agent, the transformation agent, and the personalization agent. The query agent is it started with a text to SQL layer. Vector databases also support the vector data model is kind of like the relational data model still. It's obviously optimized to support vector storage and vector searching, but you still have symbolic filters. You can still do, say, like a average of a float property, things like this. So it's kind of like a text SQL layer meets, like chatting with your data, that kind of thing. Then the transformation agent is about using LLMs to update the data that's in your database. So say you have a database full of customer reviews and you want to use an LLM to label them on a sentiment rating of a scale of 1 to 5. That's a transformation agent. And the personalization agent is particular to building recommendation systems. This is a particular niche, something that vector embeddings are very heavily used for, so it's suited to that use case. So as we release these 3 agents, we particularly zoned in on the query agent and add all sorts of new features to it, and we're announcing the query agent's GA September 2025. And so the query agent, again, it's kind of like a chat with your data layer on top of Weaviate. We have SDKs in Python and TypeScript, but it's also integrated with the database console. So you can go into the Weaviate database console where you have your data. You can click agents, and you can just start talking to your data. If you want, this is useful for a lot of people are using this just to say, get a sense of what's in the database, sharing data across teams. And yeah, so it does all these kind of things. And the query agent, case study from working with MetaBuddy, and just really excited about continuing to build this. So then with the query agent, something that we saw, because coming from Weaviate, vector database, vector search, we have tons of people who use it for search, obviously. And so we wanted to split it into ask mode, where it answers your questions, but also just search mode, building a compound retrieval system that gives you highly accurate search results. So in addition to releasing the search mode, we benchmarked it on all the popular benchmarks. Well, I'll explain that further, but say like Beer, Latte, Bright, Enron QA, Wix QA, and we tested our system compared to hybrid search, and we find really significant gains. So if you want highly accurate search results, that's what we built with search mode, and this is kind of these database agents, these agentic layers on top of the database that can help you achieve functionality like super accurate search results. And so we've also open sourced this if you want to just see like how we run these tests or verify that they were correct or things like that. Awesome. So with this talk and coming to DSPy Boston, I'm really excited so our agent services is closed source, but I'm really excited to be open sourcing some of the research we've done with developing these systems and finding these gains with Retrieve DSPy. So firstly, the dogs is kind of like, does anyone here have a dog? Give your hand up if you have a dog. Awesome. So dogs like to retrieve things. So that's kind of the retrievers, dogs, and the puzzle pieces is sort of like the DSPy puzzle piece and this kind of idea of like you're composing inferences modules to create retrievers, like a French Bulldog retriever. I think it helps kind of differentiate them also in your mind. So Retrieve DSPy is inspired by LangProbe. If you're following the DSPy community, LangProbe was an effort to benchmark the different optimized, different language models, the data sets. You have these pre-built programs, and you're seeing, for something like, say, React tool use on multi-hop retrieval, is MIPRO able to optimize it better than GEPA or Simba? And that's the idea of LangProbe. So we're trying to build on LangProbe to be particularly focused on information retrieval. So we've taken, there's a crazy amount of research that goes into these retrieval systems. It's like one of the most probably densest areas of research. Things like re-ranking, query expansion, query decomposition, parallel query writing. So we're implementing all these systems that have been published into DSPy to create a unified organization of them. So to contextualize this a little more, here's a sample of 6 programs that are currently in Retrieve DSPy. There's about 22 of them, and it's hard to even pick which ones you want to highlight, but just to help contextualize what this means a little further. So, and then at the core of these compound retrieval systems is the retrieval engine, the database. So the database is doing this, scalable, super fast retrieval, things like sparse keyword search, whether it's SPLATE or BM25, dense vector search, late interaction, or say it's named vectors representing objects with either you have more than one property that has a vector associated with it, or say a property has multiple vectors associated with it, and you have things like mixture of retrievers and that kind of thing. And then also adding symbolic filters. Just again, like vector databases also support symbolic filters. It's like a relational data model. It's not only vectors that you can store in them. So you can also filter, like say you want to have price is less than $100, things like that, and then also collection routing, storing data in multiple collections. So then on top of that, we build these retrieval pipelines. So the cross-encoder is the most commonly used retrieval system to beat just like a standard retriever only. If you think BM25 is a strong baseline for vector search, then BM25 plus a cross-encoder, that's a super strong baseline to beat with these retrieval systems. But the idea is that you have an inference. So kind of maybe introducing our first DSPy concept of the day. We have our DSPy signature, assess relevance. This is how you implement a cross-encoder with DSPy. The prompt given in the doc string is assess whether or not the candidate document is relevant to the user's query. Then you have the input fields, the query, the candidate document, and then it outputs the relevance judgment. And then something that's new to DSPy and is really cool is the ACALL support for async inference. This is huge for building these information retrieval pipelines that have asynchronous inference. And so this is like a quick, I don't know, I've just kind of sketched these up quickly for the slide, but you can see in the code to see the full implementations of all these different systems. So in addition to the cross-encoder, so the cross-encoder is a point-wise re-ranker. It compares the query in each candidate document in isolation of all the other candidate documents. Contrastively to that, you have, say, a pairwise re-ranker that's comparing 2 candidate documents at a time. And then there's set-wise, which is a funny idea, but you compare like a group of them to output one relevant one, and list-wise, where you're sorting the list. So, and then within list-wise, the naive thing to do is to give all the candidate documents to the LLM, but as things like lost in the middle and context rot and all that kind of stuff, it's maybe better to split up the inference problem, and so there are a few ways that people have found to do that. Oh, sorry. Well, all right, I'll jump ahead with that. But okay, so with list-wise re-ranking, you have, say, the sliding window or top-down partitioning. So just to quickly give you a sense of how these retrieval pipelines differ from each other, with a sliding window, you say you have 20 documents to re-rank. You start at the back, and you rank those top 5, and you kind of like bubble it up, and you have a stride window. So it's how you break up the inference of list-wise re-ranking. Compared to top-down partitioning, so what top-down partitioning does is you first rank the first window, then you find the pivot, like this is the weakest document, and then you would parallelize the inferences of the remaining batches to like bubble up the ones that are higher than the pivot, and then you recurse on that. And so, so that's another strategy for how you would break up the re-ranking task. So just kind of quickly showing, so there are all these implementations of these systems. If you want to compare 2 of them and just generally understand what goes into designing these retrieval systems with DSPy. Okay, so then within query writers, just to give you more of a taste of it, because you've seen the re-rankers, with query writers, you generally have this idea where the user inputs a query, and it could be the case that it's just like a bad query, or it could be the case that this query writer is aligned, is it knows the data that's in the database, you may optimize the query writer. And this started with Hyde, where the idea is to try to align the embedding space. So you generate a hypothetical passage that would answer the question, give the question, and it kind of like aligns the embedding spaces, and you do get a little gain from doing that. Then you have lame R, so this is like the pseudo-relevance feedback. The idea is that it takes the initial search result, then uses that to write the hypothetical passage, and then that's your search query. Then you've got think QE, which kind of the TLDR of it is you do multiple rounds of that kind of like searching, then query writing, searching, then query writing. So that's that idea. And you'll also see that these ideas are like terribly compositional. You could have a query writer that's using, say, the sliding window list-wise re-ranker or the cross-encoder, and so you can compose the query writer with the re-ranker, and that's just hopefully motivating this understanding what goes into designing these systems. So to summarize what Retrieve DSPy is, it's open sourcing some of our research behind the development of search mode. We have all these different pre-built retrievers that you can explore and test, and if you want to get a feeling for what goes into building these systems. Then we have the evals built in. So we have a collection of 12 information retrieval benchmarks that we use at Weaviate, like Beer, Latte, Bright, Enron QA, Wix QA. And then because all of these retrievers are implemented with DSPy, you can test the optimizers with them. So you could, say, train a cross-encoder using Retrieve DSPy, or you could train Hyde. You can optimize all these systems using MIPRO, GEPA, Simba, Bootstrap FuseShot, all this awesome DSPy stuff. Cool. So then, concluding thing is something that I'm just really excited to do that I haven't done yet, but I've done a little bit of this so far where I'm using the cursor chat, but I haven't built a full MCP of this yet. But using all the papers of our literature review on, on retrieval systems with the code base, and then taking a new paper and asking, cloud language models to add implementation cloud code. And so I think this is a pretty interesting direction for the future of this. Awesome. So in conclusion, if you want a production-ready compound retrieval system, you want to just quickly, you need highly accurate search results, then check out Weaviate's query agent, search mode. But if you're a researcher or who's working on, say, compound retrieval systems in DSPy, then please reach out and help us build Retrieve DSPy. And we think this is a great way that we can contribute to the DSPy community, continue to use it, and just share our experience using DSPy. And this particular context is probably what's most aligned with what we're working on right now at Weaviate. Awesome. So I'm going to hand it over to Vikram, and just thanks again for being here at DSPy Boston.
Hey everyone, my name is Vikram Shenoy. I am a senior software development engineer at Amazon. I've been at Amazon for roughly about a little more than 4 years now, and I've been with the AGI organization since its inception. And I'm here to talk about Amazon Nova customization and how to optimize Nova for your business. So before I dive into Nova customization, I'd like to go over the agenda for today. So I'll first briefly introduce the Amazon suite of foundational models called Amazon Nova. Then I'll touch base on why customization and what does a customization journey look like. Then we'll talk about the Nova prompt optimizer, which leverages the DSPy library. And finally, I'll end with some of the more deeper customization offerings that we have through Nova customization. So this is Amazon Nova. Here are the suite of foundational models that we have. So first up, we have Nova Micro, which is our text-to-text model that delivers the lowest latency responses at very low cost. Then we have a suite of multimodal models that generate text from text, image, and video inputs. And they include Nova Lite, which is our very low cost multimodal model that's lightning fast for processing image, video, and text inputs. Then we have Nova Pro, which is highly capable, which gives the best combination of accuracy, speed, and cost for a wide range of tasks. And finally, we have the Premium model, which is known for its complex reasoning tasks and is best for as a teacher model for distilling other custom Nova models. So Amazon Nova gives you a choice offering, which is the best combination of speed, accuracy, and cost, enabling you to pick the model that's best suited for your use case. So why customization? So customization turns general intelligence into a strategic business asset. It's how you make AI work for your business specifically. So next, I'm going to dive into the customization journey and what that looks like. So what we tell our customers is to first evaluate the off-the-shelf Nova models that we have. And if they don't meet the business requirements, then we do the next step, which is the prompt optimization. So we have the Nova prompt optimizer that's built specifically for our models, and we optimize system instructions and user prompts with that. If those do not meet the business requirements as well, then we start looking into more customization techniques across model life cycles. So that includes continued pre-training, fine-tuning, and alignment. So I'm going to talk about the Nova prompt optimizer, where we leverage the DSPy library. But before we get into the SDK itself, I'll quickly touch base on prompt optimization. So this is an actual prompt that we used in the demo that I'm going to show later, which is this is the initial prompt that came in, where there's a user prompt, and it has all of that information in, but it's all dumped into the user prompt itself. And this is probably not the best way to evaluate, to test out the prompt as well. So we got a score of 70% with this prompt. And we realized that if you structure the prompt better, so if you have a system prompt with static information, you have the user prompt that has the variables in it, and then you provided few short examples as well with user assistant tones, you can see the score improve as well. So the Nova prompt optimizer that we have is a Python SDK for optimizing prompts for the Nova models. We leverage the DSPy library for its prompt optimization strategies, and it's the top of the funnel in our customization offering. So how does this prompt optimizer work? So customers can come in with a user prompt and optionally a system prompt as well. and that goes into the prompt adapter. We have different adapters for taking in these inputs. So customers can either come in with a prompt only, or they can come in with a prompt, an evaluation metric, and a data set that they want to evaluate it on. So if they come in only with the prompt, we have the prompt adapter to take that input. But if they come with this metric and the data set, then we have the metric adapter and a data set adapter to take that as an input as well. We have the inference adapter as well. Right now it's Amazon Bedrock, which is our inference engine. And then we pass all of these adapters to the optimization adapter that takes it in and then results a prompt adapter at the end of it. So you can extract the optimized user prompt, optimized system prompt, and optionally a few short examples as well. This is diving a little more deeper into how we actually leverage DSPy into the Nova Prompt Optimizer. So we have a user coming in with a user prompt, optionally a system prompt as well. Either way, we first run something called a Nova meta prompter, which takes Nova's prompting guide and converts it into a system prompt and a user prompt. The system prompt contains all of the static information, and the user prompt contains all of the variables that could be dynamically changing with every row of the data set. The system prompt is then passed into DSPy's MiPro V2 algorithm, and it does the instruction optimization while we keep the user prompt static, and we run evaluations with the data set that they provide. And MiPro V2, as we all know, creates bootstrap candidate prompts as well as bootstraps example candidates as well, and we see which combination results in the best evaluation score to then create an optimized prompt adapter at the end of it, which contains the user prompt, system prompt, and few short examples that we can save as text files in the customer's local storage. Next up, I have a demo video of how this actually works. So I'm going to give it a shot and see if it's audible through this.
My name is Vikram Shanar, and I'm an engineer on the AGI customization
Is that audible?
organization, and I wanted to talk about the Nova Prompt Optimizer. The Nova
Barely.
Prompt Optimizer is an open source
Okay.
SDK that's
I want to give this a shot. I'm going to try and do this without the audio. So this is a Nova Prompt Optimizer library on GitHub. And this is a Jupyter notebook that we're going to be testing out the optimizer in. So this is, again, the initial adapter diagram that I mentioned. This is a data set that we're using. So the input is an email subject, and the output is I believe, a classification of the email with different categories, as well as the sentiment and the urgency of that email. Next up, we have the original prompt. So this is the user prompt itself. It's in a text file. It contains all of the information, as well as the variable that contains the email input. So the first thing is we want to take that data set in. So that's why we have the data set adapter here. Then the data set is in a JSON-L format, so we take the JSON data set adapter, we pass in the input and output columns, and then we just click on it hits adapt, and you can also create train and test splits out of this. Then we take the prompt adapter, so it's a text file, so it's the text prompt adapter, and you can set the user prompt and the system prompt, and this will also take in the prompt variables as well separately. This is the metric that the customer can define. So in this case, they define this metric to pass the JSON, calculate the metrics if it's a valid JSON, if it's a correct category, correct sentiment, or the correct urgency. And lastly, we have the inference adapter, which is like a Bedrock inference adapter. So we just need to specify, you sign in with your AWS credentials and then choose the region that you want to invoke this in. And that's how you can specify that over there. So the first thing that we do is we evaluate the original prompt. So we pass all of these inputs in, and we see that the original prompt, even though it gets the JSON valid, you can see that in the correct categories, it's right 90% of the time. Correct sentiment is about 50% of the time. Correct urgency is about 68% of the time, with like a total weighted eval score of 70%. And you can save these evaluations, which contains all of the inference output as well. So you can review that offline. Next up, we have the facility support analyzer Nova prompt optimizer metric. So we just tuned this metric to fit with the DSPy library as well. So this Nova prompt optimizer is going to take in all of those inputs. And first thing it's going to do is do a meta prompting. So it's optimizing prompt using Nova meta prompter. So it's using Nova Premier first to meta prompt it. And then it's using the DSPy library to generate these instruction candidates and bootstrap examples as well. So goes down, generates these examples, and you can see that we can use a prompt adapter to print out the system prompt, the user prompt, and few short examples as well. So this is like one of the examples that we printed out. Then you can save the prompt as well. It'll save it back into a text file, so you can like use that for your production use case. And then we evaluate the optimized prompt as well, because the only way we know that it's actually optimized if we can evaluate it against a metric and like a data set. So this is the evaluation score after. So we see that the correct categories went from 0.894 to 0.94, so it went to 94%. Correct sentiment increased from 0.5 to 0.65. And correct urgency went from, I believe, 71% to 91%. So the total score went to 83.4%, the weighted total score on that. So that was an improvement percentage of 18.92%. So that's a quick demo on Nova Prompt Optimizer. Next, I'll switch to Nova Customization. So under Nova Customization, there's different segments, and I'll go over each of them. So to enhance factual accuracy of language models, Retrieval augmented generation combines models' reasoning abilities with real-time information retrieved from external sources. However, ensuring that these models only generate correct but also aligned responses requires something called alignment. This is a process that's focused on shaping AI behavior to reflect human values, preferences, and intentions. A foundational method for achieving alignment is supervised fine-tuning, where models are trained on curated examples of desired behavior, either created by human labelers or domain experts. Lastly, we have continual pre-training, which keeps improving a model's capability by further training it on a large-scale, task-specific, or domain-specific data without altering its core architecture. So these are some high-level concepts, and at launch in December, we also introduced light customization approaches of parameter-efficient fine-tuning and synthetic database distillation. But since then, we saw a growing demand from customers to use diverse set of customization techniques so they can best utilize their unstructured, structured, or preference data to optimize model performance for their specific business tasks and use cases. So to meet this demand, we launched the most comprehensive set of customization capabilities compared to any proprietary model family this past July. So these are the offerings that we have since July 2025. So we also have some sample results from our beta customers. So first up, we have MIT, where we performed SFT on PhD level scientific tasks, and we saw the material design task score go from 2.7% to 97.5%. And then the reconstruction task score improved from 19.3% to 98%. We also had Cosine AI, which is a startup that develops autonomous AI software, specifically agents for software engineering tasks. And Cosine's fine-tuned Nova Pro outperformed all other models served on AWS. Next up, we have Volkswagen that performed supervised fine-tuning and direct preference optimization for a judge model and saw their score improve from 55% to 70%. Lastly, we have Amazon's customer support across industries. This was a slightly complex use case where there was a router model as well as tool calling capabilities. So the first metric that we see there, that's for the router model, that went from 64.5% to 76.9%. And then for the tool calling capabilities, it went from 66% to 86%. So an overall improvement of 5% from the current baseline. So that's a wrap for Nova Customization. With that, I'd like to thank Erica and Connor for inviting me here and everyone for joining us today. If you have any questions, I'll be available in the networking session and we can talk then. But yeah, thank you.
Hi, so Yeah, I'm Noah Zeems, and today I'm going to be presenting on the Arbor RL framework for DSPy. So a little bit about me. I'm a fourth-year PhD student in computer science at Notre Dame. Go Irish. And then I'm a visiting PhD student at MIT right now under Omar Khattab, who I think some of us are familiar with. So anyway, at Notre Dame, I'm advised by Meng Zheng, and then here at MIT, I'm advised by Omar. And my primary research in the past has been on LLM evaluation, retrieval, and then right now I'm kind of focused on reinforcement learning. So yeah. So the core motivation behind the sort of the Arbor project is that currently DSPy is primarily used for like prompt optimization, right? So that would be like JEPA and MIPRO v2. And so you can see sort of on the right, there's sort of like a pyramid, right, where sort of prompts are sort of the primary way that people use to sort of get the model to do what they want. But you can also sort of modify the model, underlying in the weights itself. And some of us may be really familiar with this from before instruction optimization and like instruction prompt engineering was a thing. Weights were sort of the only way you could get a model to do what you want. There's nothing sort of fundamentally different about the way DSPy programs are written for prompt optimization versus weight optimization, right? So the same programs that people have written for prompt optimization can also just be done and optimized with weights, right? So like, what if we just tried optimizing with weights too? Like, how hard is that? And like, how effective is it in general? So that sort of brings us to Arbor, which is sort of the library that we're creating for optimizing DSPy programs using reinforcement learning. So, another sort of thing on the motivation, this is actually sort of a false dichotomy, right? But if you look on the bottom there, so, self.generate query, that's like a module within the DSPy program, right? And, you can optimize that by sort of picking out which prompts sort of lead to the best downstream performance. But you can also optimize it by, whatever module is sort of controlling that, modifying the weights underneath, right? And then there's the other modules, underneath, append notes is a separate module, and you can, optimize that with a prompt, or you can optimize it with weights as well. And, sort of this is sort of a funny means to sort of explain, how you can sort of pick both, and they both work well in sort of their different areas, right? But it's also a bit of a false dichotomy. We've done some research sort of combining the two and showing that it actually works pretty well if you do both. So anyway, yeah. So yeah, prompt optimizers, like why, why would you want to do one over the other? So let's go over the pros and cons of a prompt optimizer, right? So prompt optimizers work really well with open and closed source models, right? So if you don't have the weights for a model, you can still modify the prompts and like have no issue that way, right? So when GPT-6 comes out, you'll still be able to optimize the prompts for that. Whereas you won't have access to the weights, so you can't do any kind of weight optimization unless OpenAI gets fancy and lets you do that, right? Prompt optimization is also extremely fast, right? There's MIPRO and JEPA, these tend to be pretty quick compared to weight-based optimization. So it tends to be pretty quick. And then also they are relatively inexpensive compared to training weights, right? You hear about there's a reason NVIDIA is such a like high-value company, has so much revenue. It's because these GPUs are expensive and renting them is expensive. So optimizing prompts is a relatively inexpensive way to sort of optimize your program. But there are cons as well, right? So you're limited by the model's instruction following ability. If this model, for whatever reason, is not good at following some instruction that you've given it, then nothing you can do to prompt it will get it to do what you want it to do. So it's just sort of a fundamental limitation of the model. Also, they can be sort of limited by the model's prior knowledge on a topic. So if you're using a model and for whatever reason it doesn't know anything about biology and you're trying to use it for biology, then it's going to really struggle to do any kind of task related to biology. So that's another con, right? So let's just go over like exactly sort of what reinforcement learning is. So the whole process, the idea here is that you sort of iteratively learn through trial and error. So you've got some sort of agent and it sort of interacts with the environment, and then as it interacts with an environment, it gets kind of some reward. And then over time, it sort of learns what actions lead to higher rewards, and it sort of optimizes itself. And if you think of it, we've already kind of been doing this with DSPy for a really long time, right? So we're very familiar with this. And if you actually look at the fundamental sort of problem definition, the reinforcement learning and prompt optimization aren't really any different. But if we're doing it with weights, you sort of allow the model to learn over time by learning in the weights instead of the instructions, right? And then in terms of just RL generally, it's sort of the underlying approach that allows models to follow instructions, have preferences, and do difficult math problems. So it's not like this is sort of like some wild adventure. Like, we already know that RL works pretty well for language models like these. We're just trying to sort of get it to work with DSPy programs. So let's go over really quickly the Arbor RL architecture. It's, I don't want to get too deep, right? But the general idea is that you'll have some sort of inference call from DSPy, and at the very top, you'll have sort of your DSPy program that you've written, right? And sort of DSPy is in charge of sort of orchestrating what's going on between DSPy and Arbor. So all of this is kind of hidden away from you. But DSPy will do inference, and typically that inference will be to the OpenAI server or to VLM or something. But in this case, it sends it to Arbor, and then Arbor has an inference engine underneath that it sends it to, retrieves that inference, and then sends it back to DSPy. So it seems like a lot of misdirection, but you'll see why we do this in a second. Afterwards, DSPy, once it's done enough inference, it'll sort of figure out how it should be sort of updating the model and what data it needs to send to update the model, and it'll send that to Arbor. And then Arbor will sort of take that data, and it sort of manages the training engine as well, and sort of says, here's some data that you need to update yourself, and then it'll sort of update the weights of the models underneath. And then once training is done, it'll send the weight update to the inference engine. So the nice thing about this is that while DSPy is doing all this inference, in the background, the model is slowly optimizing automatically, sort of on its own, right? So this is very, very useful. And if you want to get into sort of more, there's different layers that you can sort of work on RL, right? So this is sort of just a broad overview, but DSPy gives us sort of a unique opportunity to sort of figure out how to best form these groups that you need for reinforcement learning. And there's many different ways you can do this, and we've only sort of scratched the surface in the different ways that you can actually sort of do these kinds of rollouts and optimize things. It's quite a bit different than prompt optimization, and very, very interesting, and still a very open area of research. So in terms of how easy it is to actually use Arbor, right? So you can see this is sort of a section of a program that's multi-hop search. If you look, this is sort of someone using JEPA, and it's just a one-liner, and then all you have to do is just change just a couple of characters there, and all of a sudden you're using gRPO instead. So it's very, very easy to sort of swap these things out and actually optimize with gRPO. So, my mouth is getting dry. So anyway, preliminary results. So this is sort of our first sort of naive implementation of gRPO, and we've made a lot of improvements under the hood. So I think there's much more to be expected. We can squeeze a lot more performance out of this. But you can see, for a wide range of tasks, customer service, privacy-preserving queries, multi-hop retrieval, we tried out, a vanilla program using MIPRO v2, using MMGRPO, which is sort of our first initial implementation of gRPO, and then Better Together, where you sort of combine the two, like I said earlier. And you can see we got pretty modest pretty modest improvements. And like I said, as the prompt optimizers get better, those numbers will bump up. And then as we figure out how to better do gRPO under the hood, these will sort of get bumped up as well. And then the idea is that in the repositories, we'll sort of figure out what the best practices are, and we'll sort of keep those implemented so people don't need to sort of understand all the complexity of RL and all the hyperparameters and stuff. So in terms of roadmap, so as time goes on, in the past, people have had these sort of long feedback loops where they optimize and then they deploy and then sort of figure out where the corner cases are, and then they sort of optimize again. And then as time goes on, I think the way sort of Arbor and the DSPy ecosystem is going to go is sort of things will sort of narrow down where it'll get easier and quicker to sort of do these things. And then in the end, I think these are all sort of, the idea is these all sort of converge into one thing where like as much as automated and using best practices as possible. So that's kind of the sort of roadmap we're looking at in terms of continual learning. So, quick disclaimer, Arbor is experimental, right? So like don't expect the best performance out of this and, expect to run into bugs, expect to run into issues. It only works with open source models, as I said earlier. Right now, at least 2 GPUs are required, so unfortunately, it's just GPU intensive. We're working on it. All right, if anyone wants to submit any pull requests, you're free to. And then also, expect issues, like I said earlier, and definitely, reach out when you find them. We're sort of looking and trying to find as many of these as we can, but obviously we don't have eyes and ears everywhere. So definitely reach out when you find them, and we'll try to fix them as quickly as possible. So anyway, yeah, thank you. Here are some, QR codes, sort of the GitHub link to Arbor, DSPy Discord if you want to sort of talk. There's also, the Twitter you can follow at DSPyOSS and my personal Twitter. But yeah, thank you.
Hey everyone, thank you so much for watching the recordings from our DSPy Boston event. I really hope you've been able to get some value out of my talk, hopefully, as well as Vikram's talk and Noah's talk. But unfortunately, I have bad news to share about our recording of Omar's talk. Omar gave an amazing talk, as always. He does an amazing job of just communicating the passion he has for DSPy, these abstractions around declarative self-improving Python, all these exciting new ideas. Unfortunately, we we use these DJI microphones and we forgot to click the record. If you see, it has a green light when it's on and then the red light, and so we got tripped up by that, and I'm really sorry about it. We're going to do the best we can to ensure that this doesn't happen again, and well, thanks to everyone who attended the event and got to hear Omar's talk in person. It was really awesome, and I'm sure Omar will have a talk again soon that will share these updated thoughts about DSPy. In the meantime, I highly recommend checking out Omar's talk at the Databricks Data Plus AI Summit, as well as generally keeping up with the DSPy community. Thank you so much for watching this video.